I think I'll get started. We'll see if other people come in. Um, so let me start with the good stuff. Let me get my screen going. So we'll start with, I imagine, and Danny, let me know if the screen doesn't show up, but I'll assume that it does.
You can
So
hear
yeah,
it.
thank you. Awesome. Thanks, Danny. Thanks everyone for coming. Before we get to the talk, you might have seen it many times today, but I want to kind of reiterate some of the antitrust and the rules. I won't go through all of it, but maybe definitely feel free to leave if you ever feel like any of these anything in the presentation violates any of these guidelines that have been discussed. Um, and even more importantly, I do want to take time to thank our sponsor, Standard Coherent, the Gunter Group, and Posit. I'm a big fan of this conference, and I think the direction that it's going, I hope that we'll have it for many, many years to come. I think it's just an excellent job of getting tech to actuaries in a way that I don't think was available prior. So I'm a huge fan, so really appreciative to all our sponsor. Obviously there's the need to tell you that it's my opinion and my only, not the ones of the sponsor, my employer, Full Stack Actuarial, or anyone else at the conference. Although you'll see from this presentation, it won't be super controversial, apart from maybe me complaining about and or saying that I think Python is better than R. Apart from that, I think we'll stay pretty safe in terms of anything controversial. Cool. So, I think today will be interesting. You know, when I initially kind of talked to Aaron and we decided kind of on this topic, like something very introductory for Python. One thing I didn't want to for it to be, actually I didn't think about it at the time, but now I don't want it to be, is essentially a narrated version of what you can check yourself through AI, right? Like anything that feels introductory nowadays feels like, yeah, I can get it in 2 seconds, and you definitely can, right? So what I'm hoping to do, this is the last slide you'll see today. So maybe you'll be happy about that. We'll really, and we'll stay in the code on this little notebook here. We'll go through. There will be code. There will be live. But the focus, I don't want it to be necessarily on syntax. If you really are interested in the syntax that you're going to see, um, Aaron actually was able to save this notebook to the platform, the full stack actual platform. So you have your program kind of in the toolbar where you add all the different talks. If you go back to this talk, you will see that Jupyter notebook that you can download if you actually want to see it afterwards. So definitely don't worry, you don't need to, take notes about what the exact syntax or anything like that. Now, what's there is only the notebook. I'll try to find ways to share broadly, like if people are curious about the data, and because it does require a little bit of data and everything to run. But we'll get that figured out. Now, if afterwards you also have any question or can't find anything that you can find, definitely feel free to reach out. And so it's a good time to introduce myself. So I'm Matthew Plass. I'm a senior manager at Oliver Wyman. My career, well, an actuary by trade, over the past, I'd say 9 years, I've gone more and more into technology space, where that's most of what I do nowadays. Um, and so if you need to reach me, email is simple. It's first name dot last name or Matthew.Plass at oliverwyman.com, or also reachable on LinkedIn as needed. So definitely feel free if you need anything else that's been discussed or not discussed, question or otherwise. Cool. So we'll get started. You see, in terms of goals for this session, I want to demonstrate how Python is easy, right? I've seen a few names that are here that I recognize that aren't new at all to Python. So it might be a little too introductory. But that being said, feel free to ask question, right? Danny can jump in and help kind of manage that, and we can have those also at the end. Because that my goal is to help folks see how easy it is, right? And how to balance the AI and how you kind of play with it so that you know what to ask, you know what's possible. It's not about, yeah, just memorizing, it's not programming 101. That's not what this will be. So you'll see we'll go through visualization, data wrangling. We'll do not that real, but real-ish example of calculating some ADEs and go a little bit beyond in some, semi-advanced topic. Just call it that. I won't go through all this. Text is boring. So let's talk about Python. Try to, if you're in this conference, I mean, you're definitely probably interested. You probably know what Python is. Don't need to go, too low level. But I think it's important to just take a minute to kind of emphasize, why Python, why I love it. I didn't come from a Python world. I came more from a C sharp Java type of world prior. That's when I started getting programming. Uh, but Python is incredible because it truly can do pretty much anything. And over the years, it's getting better at it. And so here I say it's a calculator, it's a wrangling engine, it's a glue language. We'll see all of these, what we mean by that. So don't worry about kind of the details. But that's usually like have that in your mind. It can literally do it. Like think about it can do it. And then if there's ever an edge case, like you let me know, and then I'll stand corrected. But it is a pretty incredible. Now I'm sure you've all heard compute like maybe not all, but something that people will often talk about is Python is not as fast, right? And yeah, like you'll talk about Julia, and that's not like theoretically false, right? And some folks will say, "Oh, I'm going to go in C++, write stuff there." Um, I would say, especially if you're in an introductory talk, don't worry about that ever. Um, Python is very fast, and folks have did a lot of work over the years to remedy some of those issues. So you can assume that Python will do what you need to. And the best example was the great keynote that we had earlier, where the team from Prudential talked about their calculation engine that they do. It's GPU enable. I promise you that's they're doing a lot of computation more than probably all like most 95%, 99% actually would ever do. And it works for them. So I promise you it can work for you. Um, so the magic of Python, you'll often hear about packages, and we'll go through a bunch of them. And but there's so much more. Like, and so here, like we're look at pandas. I'm sure you've heard pandas, Seaborn, Matplotlib, Great Tables. We'll look at that. I do want to put a small note here. As we work into organization, while packages are awesome, do check with your IT teams. The rules and will change across teams, and so you can actually get burned. Some organization do not care. You can pip install. You see here, pip install. This is as complicated as it gets to get a package, right? So if hey, I want it, it does it. Pip install it, I use it. It's great. But some IT, like in it, I do understand the why. Will want you to be careful around licensing and security, and so do check with your internal rules before you start downloading because this will download and sometimes the systems don't catch it even though the IT teams might not want you to do it. That doesn't mean that there's safeguard to prevent you from doing it. So just double check. I've made that mistake a long time ago. Nothing bad happened, but you always want to stay on the good side of our IT colleagues. Now, I'm not going to go through a Python install. It's super straightforward. Everyone here will be able to do it pretty easily. But here's the link if you ever need to. We're almost at the code, but I do want to talk about this environment that we're looking at because that's like a big thing, right? When you start in Python, like sometimes I've seen folks like even very recently open like a literal like notepad to write their Python. And I feel for them because it's doable, right? But it's a little painful. So today what we're going to look at is a Jupyter notebook. It's not like the most simplest form, like a simple Python script, right? What you would normally see, right? So if I do like like that's what you might have seen or be used to, right? Import pandas SPD, and then you'd go in and keep going, and you would run that script and go start to finish. What we're going to do today, and I'm sure a lot might have seen it in some way, shape, or form, but is this Jupyter notebook has a concept of cells, right? So what you're looking here is it's a markdown cell, which is for the text purposes, and then below we have like our code cells that creates output. For people who are kind of new to this world, I like that's going to make it a lot easier because then you can rerun just bits and portions of it. So like, hey, I'm loading my data, but I just want to iterate on my graph. Yeah, you could just rerun yourself. That does your graph, right? Now there can be times where you're going to trip, where you delete a column and then you rerun and then that column doesn't exist. Now, we don't need to worry about that today. When you make that mistake, it'll be really clear and you'll know how to fix it. It's not complicated, but you'll learn the little intricacies of working with notebooks. But I do encourage you to do it. Not that saying that notebook are everything, but they're very prevalent, not just in analytics or presentation like this, or you'll see it in a lot of places where you know Kaggle competition and tutorials. But you're also seeing more and more platforms use it for, advanced data pipelines, right? So being comfortable with Notebook is a good skill set to have, and an easy one, as you'll see. Cool. So, and then lastly, the IDE, this VS Code, again, super easy, Microsoft product, um, open source, it's free. I love VS Code, and I'm definitely not the only one. It's an incredibly popular IDE where you can run all your script or all you have R, you can run it here. You have these notebooks, but you can do so much. We won't go into all of that today, but it's so much more than just your Python, right? Your organization might have data in SQL Server database, Snowflakes, Databricks, Azure, AWS, name it. And there's likely an extension for that here, right? So here I can go and look at my Snowflake data, my Databricks data, SQL Server data, right from this one interface. So VS Code I can't recommend it enough if you don't have it already. Okay, good. Enough of all this intro and everything, but if anything doesn't, feel clear, you do let us know in the chat and question. Cool. So imports, again, we'll go really quickly to those because they're incredibly straightforward. These are the packages. These are, imagine like someone else writing the Python code for you, and you can just use the outcome. That's the way to think about this. And it's an understatement how much has been written. These are incredibly robust. Some of them, to be fair, are not even just Python, right? Some of them incorporate other languages. You don't need to know that detail. They're there and they're efficient and they're powerful. Pandas is definitely one of them, but it's definitely not the only one. So we're going to use these. So obviously we need, we run it. It's awesome. And then that's all we have to do. And we run it. So Pandas, that'll be your Swiss Army knife. It's what you're going to use so much over and over again. It's incredibly intuitive, straightforward. And at some point you use it so much, that's also its strength, right? Because it can serve so many purposes, as much like from a production process to create, files for your models up to just, hey, I just want to look at a file and see what's going on to doing presentation. The fact that you're going to use it for so many things also makes you very quick at everything. And so it becomes it's the go-to that we all go for. So let's just look at it. Like we're not going to, again, focus on syntax, but we can still look at some syntax. Here, in just a few lines, with about 4 lines of code, we're just defining a data directory, which month we're interested in, and then we're loading a CSV file and showing it, right? Basic stuff, but a pattern that you'll do over and over and over and over again. Now, read CSV is as easy as you can think of. It's just a file path to, CSV. Head is just the first rows, but you can always change it, right? I can say, oh, I want the first 10 rows finally, and then it's going to give you just a little bit more rows. You can play around with it. Now, if you ever have a pandas function that you're not sure about, well, you can hover and they'll explain it. If you're like me, I hate this. I know like when you quickly and kind of know the function and you just need to be reminded of something, yeah, sure, it's great, but I hate reading that. But the good thing is the pandas especially has a great documentation, right? So you can come in and search, and whatever you want, you can search it here, right? So we were looking at read CSV, right? And you can go straight in Google. Usually I never use this search feature, but for this purpose. And now it'll probably go into more detail that you ever wanted to. But if you have a question about any of the parameters, what they do, it'll do a great job at it. I'll tell you exactly everything. Obviously, we won't go through all of this because there's a lot of optional thing you can say. And at the bottom, you'll have examples. For complicated function, you have a lot of examples. For something as simple, they kind of just say, yep, you're just going to give me a path and you'll be good. So definitely it's a great place. You'll return to Pandas doc as you kind of start using it more and more. So definitely a go-to there. Now, I do want to plug, right? Again, a VS Code thing. While printing a table is great, there are tools like it's called Data Wrangler that comes in VS Code and that you see you can click here or click here. And what's really great is you then click on that and then you can explore your data even more, right? So I just loaded this CSV. If I want to make sure that I have the right thing, I can go here and just like go around and see all my fields like, oh, my account value is great. I'm seeing my months since issue. It's a lot around months 0 to 40. You kind of visually inspect. You can filter. You can come here, add some filters, blah blah blah. It's exploratory data. Like it's not like that's not where you're going to do this. You can't do formulas by any stretch, but you can definitely explore it, which is good. And if you do want to export it, you click a little button here, and you can export it if you want to. Although you already have it in CSV in this case, so not a lot of purpose to do that. But if you take data from other source or you you know do a lot of manipulation, then you can look in data wrangler. So you can always come back to it. And if you're curious, you can always come here and then you'll see all the different data pieces that you could look at. Those were a lot of them we'll see just a little bit later. So here now, just so you use just like the data that you see here, it's completely faked. That doesn't mean anything. It was fake with Python. Like just so there is a Python package called Faker that helps us fake data where you kind of just say, oh, whether it's specific field, like you can fake an actual QSIP, where they understand the concept of a QSIP and they'll fake you a bunch of QSIP if you want to do asset data or whatnot to test out your systems. It's doable, right? So again, just another example. If you think that you need something, check if a package exists because there's a lot of niche package out there. Do be careful. Some are, you know, if you go to a package and it's like actually, let's look at it just so that right. So if I go to Faker, right? That's the so like you can always go to the GitHub package, the GitHub of a package. Do check things like versions and when it was last updated, how many people are contributing to it. Do check these little things because it's always tricky when you rely like for small analysis, that's fine. If you're starting building processes that rely on a package of that one person created like 5 years ago, they've never touched it. The chances that that's a good thing to build a long running process on, it's not going to work because maybe in 1 year there's a Python version change that you want to do, but that package won't support it, and the developer is not actively maintaining it. You're going to get into trouble. It's not good. So it's okay initially if there's no security concern, you can try it out. But I would say be careful. You can always with these packages, kind of fork them and kind of make them your own. But there's a whole set of complexities that go with that, that if you're in an introductory discussion, probably not where your mindset should be at. So anyways, so here we had CSV files. We looked at them just in a few lines of code. And then what we can do is, oh, maybe I want to do like that next step analysis, right? Which is kind of like what the Wrangler was doing, because I'm giving you like a simple example, but I might use kind of the pandas like value counts, right? So I'm just selecting a column, doing a value counts. Hey, boom, I can print it out. Now this is ugly. This is really hard to, if you know exactly what you're looking for, that's fine. Like there's no problem looking at that. Now you can go one step further and just doing this little kind of plot for a bar and put a little title on it, and you say, oh, okay. I mean, I'm getting closer, but it still is really horrible to look at, especially that this is not the ages are not by ascending order. They're by actually they're sorted on the counts. So there's no clue to know I don't know what any of these ages are. Now you could do stuff like, hey, only show certain blah blah blah, and that's what we're going to show you here. And that's again the one thing I want to emphasize. It's always small little things and it's usually functions that exist. You don't need to go writing a bunch of pure Python code, not at this level, right? Usually the things will exist. So if I want to use age bands, I use this function. Now, that's where ChatGPT, Gemini, or whichever AI you use is great, right? There's nothing wrong with saying, hey, I need to create age band in pandas, and It's going to tell you exactly the one and show you a snippet, and you might not even need to go to the Pandas documentation. That doesn't mean don't understand it. Like definitely understand why what it's doing, why it's using the parameters that it's using. Otherwise, it's not, you're going to have trouble down the road. Like if you just have a bunch of code that you just had AI produce, I promise you, it will be very excited at first because it's super quick. But if you literally don't get what's happening, it's going to bite you. So use it. It's going to speed you up, but don't only. It's an assistant. It's not the actuary, right? Always keep that in mind. But still really cool. Like in the one line, I create my age bands. Great. Like I give it the bins and the labels that we've created above here. And again, like you can look at the syntax afterwards, but very simple stuff. Like a lot of actuaries, while they might not have been exposed to Python, whether it's in actuarial models or VBA or others, are quite familiar with formulas. Like that's not a complicated thing, and I know all actuaries can master this very easily. And then now if we do the same thing that we did earlier, but just now using this age band field, everything else is again same basic plot that we're doing. Now we get something that's readable, which is awesome, right? Now, there's nothing exciting about that graph. It's very first level. And you can always tweak it. We'll see later, right? That's the way you should think about it. It's building blocks. At first, you get the data, you look at it a little bit, but then you refine. Either you do more manipulation to the data, calculation, or if there's not a lot to do, but then you just do cleaner and cleaner visualization, and we'll show kind of both things lower. Now here, when we get to the calculation, that's where I'll be very mindful around spending too much time on the different functions, but it's always good to look a little bit of it, right? So here, very basic thing. I got two CSVs. I very randomly chose RP 2000. It doesn't mean anything. You'll see the ADEs don't make a lot of sense, and that's fine. These are very, very basic tables, right? Like if we look at our data here, where's my the RP will be, right? So if I look at one, it's just age and rate. That's all it is. Now, it's always good to work with one, like your mortality as one table, right? And so what we do, we load each in a pandas data frame. Now here we say, hey, let's create a gender column, assign, you know, the right indicator based on where the table actually was. And then we essentially concatenate the two tables together, the two data frames together here. You put the female male together, and then you're going to have a RP data frame that you can then use. Here, again, I'm sure you'll find it very straightforward. Just rename and you tell it the columns. You can't guess that. That's the other thing, right? That's why you will be searching things. You'll be looking at things. Now, people might tell you like, hey, you could have done like RP and that's your data frame, and then you say dot. And then yeah, you can, if you're like in an IDE, you can see a lot of these things and see, oh, it can do cool things. And if you're working with a small package, yeah, that's great. Like there won't be that much, and maybe that works well for you. But when you're working with pandas, I mean, the list is incredibly long. I don't recommend initially approaching it that way. It's going to be more annoying than good, but know that it is there, right? Using autocomplete is great. Like I'm not saying not to do it because you'll find a lot of times it'll save you. It's not necessarily where you learn, but it's great just to code a little bit faster. Now afterwards, like we essentially, I'll kind of open these code cells, just that we look at it. But we create like three functions, very small, right? One just to convert annual to monthly. It's a very basic one. Don't need to look at that. This one slightly more, complicated, but not really. It's just we create these functions just so that it's, a little bit easier to read. It's not like in this code we're doing any very heavy lifting, but it's still good that we have kind of clean files, clean patterns. So it's easier to debug, but also just to maintain. Right. So this one, function definition, if we take just a second to look at those, put a function name, parameter one, parameter two. Those are optional in Python, right? You don't have to say what it is, but I love to just say, hey, it's a data frame, and this one is another data frame. It's going to give you a data frame. Now, why do I really suggest you do type hinting here? Is, for example, here, I've already told it, like I say, if I say policies at DF, yeah, I've got it. It's matter if I'd say here, then it's going to be able to autocomplete for me. If I didn't tell like the IDE, hey, it's a data frame, but then it wouldn't know when you say the dot, it say, yeah, this could be a string as much as a data frame. I don't know what you're asking me, but then if I want to say merge, yeah, it's there. It knows, and then that's how it's going to offer this to me because it knows what I'm doing, and so really recommend going with type hinting as much for the parameters as what you return here. This little thing says I return another data frame. The rest you'll see very basic stuff, right? Like we're just merging, which kind of think of a join in SQL, left on, right on. I'm sure you've seen that. This is a left join between the policies DF, which is your left table, and your mortality table, and you're essentially just adding your QX to it based on age and gender, and renaming a few columns. That's pretty much converting to monthly, that sort of thing. And so at that point, when you're kind of done through here, when you return merge, you essentially get a data frame that you had with your policies, just with your QX attached to it for that specific time. Now I'll go through a little quickly to this because that one is more of a look at it if you're interested afterwards. But we build your A to E. I do want to emphasize this is not a lot of code, right? Like we have, I don't know, maybe, 20, no, not even like 10, 15 line of code. And what this does, it actually, takes your transaction files, take your actual inforce and create A to E's. And so here is when we run it. And you see the last time I run it took 6.3 seconds. Now, that's where we can talk about a little bit of the efficiency of computation. 6.3 seconds is actually slow, right? That's like for what we're doing here, it's a little annoying, but that's more of a concept of this function was meant to be simple, easy to read, and bear in mind that I'm taking like 24 months. That's about 5 million rows that we're going through. And so now when you kind of put that in context, okay, I didn't really think about computational efficiency. I kind of just willy-nilly put some code together. It's still 5 million rows that I've processed to calculate an E to E. 6 seconds doesn't sound that bad. I mean, this is not like a slow Excel file. It's working great. And I'm going to work off of that very easily. Well, then 6.3 seconds is fine. I don't want to bash on Excel. I always bash on Excel, but I know we have like there's talks that either you might have seen or can see in the recordings. Yeah, Andrew Chen, but I know like Brian Robidoux. There's a lot of folks in the industry who know how to make the most of your Excel file. So anytime that I bash Excel, I do know you can make it good. I've never really spent a lot of time doing it. I just prefer here where we could have had 10 million, we could have had 30 million rows, and it would have run perfectly fine. And so to me, that's the great part. Now, at some point, it's the runtime is going to be too long. You're going to find it too annoying for your process, right? If something that you run often, or just the amount of data keeps going, and that's where you start refining. You start saying, okay, where am I taking a lot of time? And as you kind of get more familiar, you'll get the little tips and tricks on how to make it faster. And then you'll see it'll be awesome, and you'll do because you could like if you build it correctly, it should be much faster than that. But 6.3 seconds ain't too bad. And so now what we get is this very ugly table that gives us our ADE for every month that we've processed. And so that's where we get kind of in the visualization portion, kind of looking at some of the other packages. I like Seaborn as a simple, easy to use package. There's so many. Obviously, Matplotlib is what you'll hear a lot, which is kind of the more basic versions. The core version of visualization in Python. But there's so more. Like Plotly is a very popular one. And there's much more. If you Google like Python visualization packages, it'll offer you a bunch of choice. And it's a mixture of style, right? The way you provide the information to the package is very different from some of those packages. Some of them you'll find that it just fits the way you're thinking. And then you'll say, I love it. And then some I hate and I don't ever use. Even though they're pretty, I just don't like using them. So you kind of find the one that fits for you and you kind of do it, right? So here, I like Seaborn. It's super, super quick. Now, it's more than what we had earlier, right? If you remember, we had just we had our pandas, like if we go above in the previous chart, like it wasn't great, but it was literally half a line, right? We just added plot. And that's, pandas using matplotlib or other packages behind the scene, and it just asks you a little bit of simple parameters to do a simple graph. But if you want to do something that's just a little better, then you just need to provide a little bit more, right? So you start providing some sizes, and then get some titles, some axes. This here is to add like that line at like the 100% E to E, that sort of thing. And then, oh, okay, like we have like rotation 50, 45 degree to just put more of them so that we see it. By no means is this going to win any prize, right? Like I think we can agree on that one. Um, but it'll get you there, right? And then you can refine. Like think about it that way. It can look as good as you want it to look good, but it's a little bit of an exponential curve. Like those last 10% are a little bit of more work to get to, but they often are worth it. Because you're gonna build, like you can build this into a function, and you can even put like your company's color theming and everything, like even like your font theming. Like I've seen companies like have a pretty robust like style guide, and then you can use those every time you run any process report. You can just call that function, oh yeah, create my graph X, and then it'll always have that great style that you love, that you've tailored. So definitely keep that in mind. It's like obviously if you do it 2 seconds, it looks okay. I'm not saying save that in a package that you can reuse all the time. But if you say, hey, you know what? Like I do these tables all the time. But yeah, create a function, work with folks within the organization that might know how to create a package of it. Like we're not going to go through packages today, but it's definitely worth looking into. Because then that's when Python becomes great. Because why Python versus an Excel file? But yeah, it's not just that it can handle data size. Like, yeah, for sure, super efficiently. But it's also like I think you can have really strong reusability across, right? You create that package once, and then all across the organization, everyone can access it, right? You could have had like you might have a package called uh, you know, org style graph, whatever. And then every time you run something at like in Python at the start, you say import org style graph. And then you don't put any code on it. You just call this one function. Everyone in your organization can call that function. Same goes with other work that people do. So there is a lot of like snowball effect when you start moving more people to using Python in their day to day, not just for like that enterprise, project. You kind of build off of each other. So I do suggest it, especially in terms of visualization. Otherwise, you'll find really annoying the time you're going to spend if you just use it once, like to make it really, really pretty. Now, I am a big fan of tables. And so there is this package called Great Tables. I like to have pretty looking tables. I hate tables that look bad. So like when we were looking earlier at this table, not everyone is going to feel that way. I just couldn't stand it. And so they've created great tables. Now, even though I don't like R, a lot of awesome packages come from R. So, maybe I should rethink that position. Um, Before we go to the code, I do like for package that you use a lot, always remember to look at the documentation. Um, like this one is a great example, right? So this is the great let me zoom in a little bit. Um I think they've done an awesome job, right? Because again, it's visualization. So it's not necessarily always the easiest stuff to do. And they've managed to say, hey, we're gonna create this concept of a table and they're gonna explain it to you in a very, very simple way, but it's not a simple package at all, right? But they provide you good documentation and then you're gonna have examples, right? So you can go in examples and hey, yeah, I love a table that looks like this or like that or has like these little fields here. Let me see the code for that. You can do that. They'll have good getting started stuff where, hey, it starts with an overview again, that thing, and then you just keep going. It's going to start simple, explaining you how to do it simply, all the way to, you know, more like nano plots where you can create like cool plots inside your table, right? It can go very advanced. And so knowing the documentation is great because it kind of comes back to your relationship with the AI. If you ask AI, can I have a great table? Yeah, I'll give you a table. They may or may not. Like sometimes, like I was asking, like testing out stuff, and sometimes it doesn't know that a package exists, even if the package exists. Like that can happen, right? Not often, but it can happen. But you're also limited by what you're asking. If you're asking, like, I want a pretty table, it's gonna give you a pretty table, but it's not gonna start creating graphs like this, right? Because you haven't asked for that. And if you don't know that you can ask for that, you're not gonna ask for it either. And so that's where it's so important to have that curiosity. That conference like these are awesome, right? Because you're gonna see like this is intro. We're not looking this is the most exciting stuff ever. But as you see people doing things, you're gonna pick up, oh wow, that's cool how they've shown, did that, whatever. And you're more in that world, you're gonna see the universe of possibilities. And then you're gonna start asking better questions to the AI and start unlocking really kind of the cool thing about pandas. About pandas, but Python, I'm sorry. So if you're kind of curious about the code, kind of ignore this piece was just a few lines to modify our data to add like years and month name, but really the great table code looks something like this. So, you kind of call like this is what we imported, right? At the start, we said import great tables like from great table GT, right? And so we use the GT class, and then we define it that way. We provided, a data frame. That's the data it's going to use, and then a few just parameters. Not actually a few, a lot of them, right? But they're well kind of broken out, right? I say, oh, my headers, my labels. Yeah, that's very straightforward. Like the first time you wouldn't know, but every time you use it, yeah, it's easy. Like it doesn't take, you don't need a degree to do this. And then here, like, oh, I want to format numbers, and I say, oh, all of these column, I want to apply this, and it's a zero decimal, and this A to E, I want it to be a percentage format, and I want everything centered. That's it. Grade tables are another place where, like, if you want to really tweak it, you can tweak it quite a bit, but I do suggest using function because you can spend a good amount of time making them look just right. But I do like it, right? And so not that much a line of code. That same table that we were looking at, it now looks like this. We're getting really closer to something that can be used in a report, right? Like that starts to be very reasonable. So the one thing that's a good plug is notebooks, and people might come from the R world, kind of know that from the R markdown options, is that now this was not like this notebook was not built to be, something that I, present to kind of do a PDF and share at a company. But you can build it, right? You can build your notebook in a way that you create PDF where it hides the code. And yes, the code produces everything, but you can have something that's shareable. Now, there are great tools. So I'm gonna, plug Quarto is a great tool, and there's a bunch other. If you get interested in that, yeah, again, Google, right? Python, PDF, generated report, notebooks. It'll give you a bunch of stuff. I'm a big fan of these type of reports. I think they're much better than Word because, I'm not pasting around a bunch of graphs and tables and doing manual formatting. So I hate that stuff, but to each his own, I guess. But know that you can make it look good. You can always make it look good, and there's a package out there for it. Um, I don't want us to gonna go to the full hour. We're going through a lot, especially if this is an introduction to you. So I do want to leave time if there's any question, and otherwise, it's okay to keep it short. Don't want to overload anyone. Um, as we kind of seen, like if we take a recap, what we've looked so far is, hey, Python is simple. You want to use these packages, yeah, you pip install, you import them, you're done. You're leveraging them. It's awesome. You just read CSV files, you um, tweak a few lines of code to make your data go in any shape or form. Pandas can literally do anything you'll want to do it with it. Your data, if you have something in mind in a tabular format, Pandas will get you there. And then we've looked at Seaborn for graphs. We looked at great tables for tables, which is all great. But the last topic that I want us to look at is kind of expanding that scope for you, right? Because it's not always CSV, right? It's you got data everywhere, and that's one part of when people say Python is a glue language, is that it can get everything, right? We before we said, hey, you can have data in a bunch of these modern platform, either like a cloud-based SQL Server, Databricks, Snowflake. You can have probably two, three lines to get data from these platform into what you're working on. Obviously, you can also work within those platforms, but that's another topic. But it's awesome that you can get data from anywhere in any shape come together. And so I'm going to show you a very kind of slightly more advanced topic, just so that it kind of kind of maybe pique your interest on that one, not necessarily expect everyone to be expert in it. And the reason I said, like I was debating, should I talk about APIs? It's not the most simple kind of concept, but I've, been doing a lot of project recently with companies that are, doing a lot more Python broadly to the company, expecting actuaries to onboard and use it. And that, we use the word API nonstop, right? And people's like, yeah, no clue what you mean. And right away, the conversation started, and people feels like, oh, that's not for me. That's too complicated. That's for other folks. That's for tech folks. But not at all. It's like we use acronyms like the same way non-actuaries will feel when we use some of the actuarial acronyms. It's the same thing. It's not complicated at all. So my goal here is just in a few lines of code, start demystifying, but also more lowering the bar when you hear these things. So when you hear API, think of it as just an in between you and something you want to use. That's the way you should think about it. It's used a lot and not always correctly. And there's a lot of context. Today, we'll just kind of think of it in terms of database, but a lot of your actuarial system that you use have APIs to them, right? There are actual like projection system, vendor system out there, or even homegrown that also have them, where you could have a one-line Python code that says, "Hey, start, my projection model in one line of Python." Obviously, the system itself doesn't take Python code. There's something in between that receives your Python code and then tells the system. And what we're going to look today is the same thing. We're going to look at like rates data that's on the New York Fed kind of database, and we're going to get it by simply Python calling this URL. Python's going to call the URL. The API at the Fed, the New York Fed, is going to essentially receive it. It's going to know how to talk to its database, right? Where the data is. You don't need to know what's the name of the table, the field names, the whatever. You don't need to know any of it. Like that's what the API is for, is that in between, you and that data, and they maintain it. And so you just call it and you get data in a certain format. The beauty is that format will be easy for Pandas to consume. So if we look at here very easily, you provide that URL. Now, I mean, I've added the numbers of days. Like this is a so for last X days, right? Which you might need for, maybe your ESG or whatnot. So, hey, I want 200 days. I could have done it, in even years, if we wanted to. And then we use this URL. We define it. The headers, don't worry too much about it. That's just this specific API that needs it. But since it says that we accept anything that's in JSON format, and then that's what I want to again reiterate. These are kind of really the main two things that are happening here. Whoops, sorry. We call like, this is the request package again, package magic that says get that URL, and then I'm going to take that request and I'm going to call JSON function on it, and I'm passing that to Pandas data frame. These just two line, right? Because yes, we wanted to do it correctly because we wanted to have the URL specified below, but it's essentially two line to get actual data from the internet right here, live data that you can now use in your process. And you might have like that's one piece of data, but there is a lot more out there that you can use, right? Some are not free, right? We can't always show them here, right? So you might have, paid data to get actual asset information based on the QSIP. Those are never free. But you also might, like we were talking about, like actual vendor system to either run, but also get your actual output off of. So there's a bunch of different APIs that you can use, but that's where it's so simple. Like, and these were just kind of to clean up some of the look. But like in 2 seconds, this is data that I just took from the web and I can use in my process. And then if people are curious, because I know I want to stop at time because I don't want to take question. I want to kind of
Well,
get to the question.
yeah,
Yeah, go ahead.
Matthew, we do have a couple questions. We have a few questions. So when you do reach a stopping point, you do have a few in the queue.
Awesome. Yeah, because we're at the stopping point. Like here, that's more like if you're curious, like again, it's like in that next level, slightly more kind of defining visualization, but then boom, we kind of get you know, a kind of good looking sulfur graph if you want to review what you just did, right? So again, getting stuff easy, viewing it. I find these kind of this Python glue concept, like that's what makes it really exciting. But hey, I think it's a good stopping point. We're at the 45 kind of minute mark. So yeah, let's take question. Let me get back to the chat. And yes, if people are kind of figuring out for some reason, Zoom is kind of the bane of my existence. So do bear with me. We give actually. So the question is, what groups of actuaries are using Python? I'm assuming it around the edging department, experience studies. Is this correct? Um, you'd be surprised. Um, you're definitely right that like in stuff like you're talking about hedging, so like quant side of like our Prudential like colleagues were talking earlier today, those are definitely groups that Python has been around. So you're 100% right there. Experience studies, yes, that's another like groups that are very data focused, right? They've been for a long time. We do see it. But what I'm seeing though is kind of that other shoe drop. Like we're seeing it broadly. Like there's a lot of data transformation in the industry, which they're not about a specific group. It's about bringing it to the entire organization, right? It's a different way of working. So it's definitely something that's in progress. It's not something that's there yet. But all the organization that I've been either have moved or are in the process of moving to a broad use of Python. So I think if you move 2 years in the future, I think it will be very, very broadly used. Not saying everyone, right? Like I'm not saying that every actuary is going to be a coder, whether from a level or what you actually do. It doesn't always make sense. Um, but it's kind of saying not all actually use every function of Excel, but Excel is not on one group in particular. I think the adoption will be very broad in that sense.
And then Matt, you probably want to jump down to the question from Jehu at 11:39. And Jay, I'll just chime in on that. I'm not a developer, but I work with a variety of actuarial developers, and they are definitely using GitHub Copilot, and I've heard some good things about it. But I'll let Matt speak to it more closely.
Am I getting the right?
Question to presenter: have you considered using GitHub Copilot AI extension with the VS Code?
Okay.
Oh,
Yeah,
that one.
yeah, I think our time zone are kind of messing up here, but yes. So yes, so GitHub Copilot is a great opportunity. I'd say that's going to be a lot with your organization. I've seen like probably 4 or 5 organization, and they approach it very differently in how they integrate code, right? Some like Claude, some have something with ChatGPT, and they don't like it. So, which one you use and where it's enabled by your IT firm, I'd say. And sometimes, like to be fair, it's like you can not everyone will block it, right? Some firm will let you use whichever, like there not be an actual wall. Again, be very careful. Like I don't think there's any wrong when you do very generic questions, but definitely make sure that your firm has it set up anytime you use not just real data, right? But even your actual models or anything that could even feel proprietary. I'd say be careful. But yes, I think the use of AI is a must, but you got to be very careful because even I'd say over the past 2, 3 weeks, I've seen AI make many mistakes, and I'm talking the newest models, and I'm talking different models, not just one. Where I'm trying to use it to kind of sense check what I'm thinking, and they're like, "Oh yeah, no, you can't do that." I'm like, no, I'm pretty sure I can do that. And then I look in the actual documentation of the platform. It's like, no, I could do that, but 2 models told me I couldn't because it was something that was new and not well documented necessarily or clearly. So the AI didn't really get it, but it was doable. So be careful around that one. It's definitely and when your code gets big, like again, the Prudential team was saying earlier, sometimes like they'll struggle. So use it, but don't depend on it. That's probably the way I would think about code AI, vibe coding. Um, anything, Danny, that you've seen that I should highlight or just gonna
We got a question on using CSVs. CSVs is fastest for loading flat tables. However, considering the magnitude of data, it is still by far the slowest part of the actuarial
yeah,
system.
yes. Yeah, exactly. Now, what you're going to see, like CSVs are prevalent, and for a lot of tables, it's fine. But when you're talking about actuarial results and things like that, that's there's a lot of formats, file size. Like you'll hear stuff like Parquet, which they are great. Now there's always like your use case. Always be careful. Like if you're doing a quick analysis, it's fine. Like even something takes 10 seconds. But when you start talking about repeatable processes, yeah, you don't use the right file format, and Parquet are a great file format. Now, to be fair, also use modern data platform is what I would suggest, right? Like I think these platform, right? There's a bunch of them, right? Whether you're talking about Databricks, Snowflake, Foundry, there's many options out there. They all allow you to not use flat files because you shouldn't really go too much on the flat file size. It's all, like sometimes some systems don't have good connection and you'll have to do that. But when you can avoid it, I would say definitely avoid it for like big processes. Because you kind of want to keep data and compute close to each other, right? And not have to rely on those. Because yeah, the loading will take a lot of time. It won't be computationally efficient. From for a lot of the use case that you're gonna have to deal with, as opposed to if you these modern, like if you use Parquet or there's like for people who are interested in data, like not new, but that's getting more and more traction, right? Iceberg tables, like these are type of things that they're awesome. They are limitless, right? Like having a table that can have, you know, 500 million rows and you're not scratching the issue here. It's easy and you can compute it in 2 seconds. Yeah, that's awesome, right? Like I could show you example here, right? From a database where I can do a query that I did it just before, took about 0.7 second and it was querying 300 million row table because it was in the database and the compute was happening there. I'm just going to receiving it. That's efficiency, and that's what we should try to move forward. And a lot of the data transformation project are doing exactly that. Yep.
So here's another one from Neil. You mentioned creating functions to leverage code you expect to reuse later. There's obvious coding efficiency from doing this, but are there any material computing performance implications?
I'm guessing you mean like of wrapping it inside of a function. Um, the fact the concept of wrapping it inside of a function is you can assume that that's not an issue in terms of overhead. Now, depending like what I've seen where that becomes, not necessarily an overhead in terms of compute efficiency, but you some folks you might have heard like because it's a pretty common like OOP or object oriented programming, right? And I come from Java, C# type languages, which those are centered around that. So when I came to Python, like I was trying to build objects of everything and methods of everything and did a lot of overhead. It's not like computationally didn't really make a huge difference. It's more that the code was just very annoying to look at, right? Simple is good. There's no need to over engineer. Now, sometimes the problem is there, and you do need to engineer solutions for that problem. And sometimes there is such a thing as too much function. Right? Like sometimes, like if for say like this thing here, I create a function that's like you know, get fed JSON, and the only thing it does is it takes a URL and then returns this. That's not good. And it wouldn't follow like general Python concept or what's considered Pythonic, which is like you gotta be careful around efficiency, both computationally, but just the number of lines and it needs to be readable. And so if you have, if 7 lines of code becomes 5 functions, something is going wrong. And you laugh, but that actually is something I've seen. And sometimes folks go a little too extreme and say every line is a function almost, which that's not good. It's not necessarily a compute issue, but it's just really hard to read and maintain.
So we have a question just in general. How do we install Python so that everyone has access to the exact same packages, notebooks, and get passed around? Kind of like
Yes. Yes.
that, the general maintenance of keeping everybody on the same versions, essentially.
Yeah, yeah, that's a great. So definitely we won't go into like all the details. Now often like your company might have control Python installation, right? You might have a software center or whatnot that will force a install of a Python version for you. That could be the case. Or they might say, no, like a lot, what you'll see in a lot of places, you can download the Python you want, but a certain project will essentially have one version. And now what you can explore is something called like Python environment, which is what I'm running, if you're kind of curious. So if I go like terminal, it's kind of like a best practice. I created like an environment just for this talk, right? Because I ATS Tech Summit, right? Actual Tech Summit. And so this is where I have the Python version that I want, the package and their version, right? Because not just the Python, but the version of your separate packages that you run. Everyone should be on the same. And when you start working this big project, whether it's through environments and you'll have like little files called like requirements, which will tell this project or repo in GitHub will tell you, hey, this is the packages that we're using, the version of these packages. So there's a lot of stuff out there because it's a great question because being on different version will mess things up at times. And so there are things that just weren't there if you like I've seen someone recently that was like on the 3.6 or something of Python, and I'm on 3.13. There's a lot of stuff that I'm using that probably didn't even exist at that time. And so that's something that you got to be very mindful of. And there's a good amount of tools that supports it. But I would say go through either your IT. You can have distribution like can look to like Conda, like Anaconda. That's another that can manage like a package management and version, and then just general environments or Pi environments
And I would
will
also
be good
just
place.
add in a lot of firms, a lot of bigger companies, you could have things like a Python community of practice, right? You've probably
Yeah,
had interacted with community of practices in different structures in different companies for all sorts of different activities. And if you have something like a Python community of practice, something that they would manage as well as they would help keep those things aligned.
yeah, it's a
Uh,
great call out.
one other question is anybody have, Matt or anybody, suggestions around bulk uploads to SQL Server from Python?
Hmm.
Alchemy and Execute, and many is very slow. Just kind of
Yeah.
doing that.
Oof, you're right. So there are things that you can do, right? So like to speed it up, but in reality, it's true that that is the slowest part of your process. That's going to be. So we won't have time like in a minute to go into optimization. There's a few things that you can do in through SQL Alchemy and kind of chunk your data, and you could even, depending on what you're loading, most likely you could load at the same time, and there's ways to improve that. Your SQL server can also be, if you're, I'm not sure if you're using a local SQL or something like in Azure, you can definitely bump up the performance of your SQL server in Azure, which kind of all would help you. Now, always keep in mind though, loading to your database is slow. That's or doesn't have to be slow, but it is usually a bottleneck. But it's also why I would suggest like that you kind of look into patterns where you save data to something like an Azure if you're in the cloud, something like an Azure Blob Storage or an AWS S3 buckets, because a lot of these platforms, depending like yes SQL Server, but also other data platforms have kind of optimized data transfer that kind of take those very efficiently and load them. So there's way to go about this. Happy, we know we're at time, so feel free if whoever asked the question, but LinkedIn or email, I'm always happy to have those chats because that's a topic that actually we were dealing with that on the project very recently on optimizing data load to various databases. So always happy to have those conversations.
Mhm. Think that's it in terms of our questions. Thank you, everybody. Thank you, Matt, for presenting. Everybody
Awesome.
have a great day. Thank you all so much.
Cool. Thanks, everyone.